Yes.
Yeah.
So I think last class we started with the graphs.
Yeah, we started with the graphs, and the last graph we did was logarithms.
Logarithm graphs, yes.
Yeah.
So today I'll start with the property of log. I'm sure you would have already done it in your ad maths.
Yeah, I think so.
But just a quick revision of properties of logarithms.
Okay.
So starting with the first property, log of m to the base a, log of n to the base a.
Yeah, log of m. That's going to be log of mn.
Mn
right?
to the base a. Yeah, provided these all logs are defined. Okay.
Okay.
Now, how does this property come about? It comes about from the very basic exponential laws. For example, if I call this as p and if I call this as q. So when we say log of m to the base a is p, m becomes a to the power p.
Yeah, correct.
And this becomes n becomes a to the power of q.
Yeah.
Correct. Now, when you multiply mn, when you multiply these two, you get mn is equal to a to the power of p plus q. Which is as good as saying log mn to the base a is p plus q.
Correct.
And that's nothing but log of m to the base a plus log of n to the base a.
Oh yeah, okay, got it. Yeah, understood.
And this can be extended to any number of logs. So if you have log m, log n, log p, log q, like that, it'll keep on getting multiplied over here.
Okay, yeah.
This property is very useful in performing calculations, in doing calculations. So in JEE and other exams, probably calculator is not allowed, and many people prefer using log tables for doing the calculations, complex calculations in chemistry and physics. In physics, you will have modern physics, which involves a lot of calculations, and there you'll be dealing with a lot of numbers which are having higher powers and a lot of decimal places.
Okay.
So this property is useful in that regard. Next property is log m to the base a minus log n to the base a
equals log m by n.
Is log m by n to the base a. Yeah. Again, the proof is similar to what we had done in the previous one, so I'm not going to do the proof here.
Okay.
Log of m to the power n to the base a is n log m to the base a.
Yeah.
Can you prove this quickly?
Log a equals n log m to the base a. So how would you prove that? Okay. Okay. So at first you would do log a. Never. Oh, okay. Second. Actually, I'm not very sure. How do you do it?
Okay, so let's say log m to the base a is x. Okay. So m is a to the power x.
Okay.
Correct. So m to the power n would be what?
M to the power n would be
a to the power x whole to the power n, which is nothing but a to the power nx. Correct.
Correct. Okay.
Which is as good as saying log of m to the power n to the base a is nx.
Okay.
And
Yeah. Okay.
x here is log m to the base a, so you can replace it over here, so it becomes log m to the base a,
Okay.
and hence the property.
Okay. Got it.
Okay. Again, these two properties are useful in calculations.
Okay.
So if you have to raise a number to a power, then this property number 3 will be useful, and if you have to divide two numbers, then property number 2 will be useful.
Yeah.
Going to the next property, property number 4, log of m to the base n can be written as log m to the base a by log n to the base a. This is called the change of base property. This is called the change of base property. This type of property is useful in answering questions like what is log, let's say, 64 to the base of 16.
Yeah.
Okay. Now, if we start counting powers on 16, 16 to the power 0, 16 to the power 1, 16 to the power 2 exceed 64, right? So we cannot find a power like this because we only know how to, calculate powers of natural number manually. Else we have to use a calculator. So in this case, is what we do, we try to find a number which whose power contains 64 also and whose power contains 16 also.
4. Yeah.
4 is such a number whose power will contain 64 also, 16 also. So what we'll do is I'll choose a suitable a. Here it is 4, and I will do this calculation. So when I do that, this numerator becomes 3, denominator becomes 2.
Oh, okay.
That means log 64 to the base 16 is 3 by 2. That means 64 can be obtained by raising 16 to the power of 3 by 2.
Yeah.
Okay. Again, so this is just a verification that we did now. Can you prove this property?
Of this? Okay. Oh, okay.
Can you prove this property? Try it out.
Okay. Fine. Okay. So log m base n. Okay. I'll equate it to something. Say p. Then n to the power p equals m. Okay. Then if n to the power p equals m, and here you have log log m base a by log n base a. Okay, and then if I have this, then p equals m to the power p by.
Do you need my help here?
No, let me see.
Okay, yeah. Try it out. Try it out.
Oh yeah. Okay. I think we're getting it. 1 second. So this so basically I did n to the power p equals m, and then wherever m was there I substituted n to the power p. So now it'll be like p log n base a by log n base a. Okay, and then I think I can cancel out log n base a and log n base a, and that gives you p. But p so p was the same thing as log m to the base n. So I guess that proves it.
Okay. So I have some different approach. Let's say log m to the base a is x.
Okay.
And log n to the base a is y.
Okay.
So from here I can say m is a to the power x.
Correct.
And from here I can say n is a to the power y. Correct?
Yeah.
Now m, which is a to the power x, can I write it as a to the power y to the power of x by y?
Okay, wait. So m equals a to the power x.
Yeah, and a to the power x I have rephrased it as a to the power y raised to the power x by y.
Okay, fine.
So which makes m is n to the power x by y.
Correct.
Because a to the power y, this term was actually your n.
Yeah.
Yeah.
Okay.
So that means log of m to the base n will be x by y,
Correct.
and x itself was log m to the base a, and y itself was log n to the base b. A.
Okay.
Okay.
But yeah.
Easy. So this was the critical step in this problem.
Okay. But what I did was that right?
Yeah. That was also correct.
Okay.
Okay. Now log m to the base n is reciprocal of log n to the base m.
Okay.
Can you prove this?
Reciprocal of log n to the base m.
Yeah.
Okay. Okay. Now, how would I find log n to the base m? So if log m to the base n equals something, then n to the power x equals m. Okay, if n to the power x equals m, am I getting somewhere here?
You can use the previous property itself.
Oh, it's related to the previous property? Okay.
Yeah. It actually means you have to prove this. This into this is 1.
Oh, okay. Fine. Okay.
I'm sorry.
So if I have to do that, then log.
Then you can change the base.
Huh?
You can change the base over here. Correct?
Yeah, change the base to a. Okay.
Here also you can do this. Correct?
Yeah. Okay.
So this gets cancelled. This gets cancelled. This gets cancelled. You get a 1, which is your RHS.
Okay. Yeah. Got it.
Correct?
Yeah.
Okay. Next property. Property number 6. A to the power log m to the base a. A to the power log m to the base a is m itself.
Okay. A to the power log m to the base a equals m itself.
Yeah, and this is a very, very widely used property, and you'll find this property used so many places in your class 11th.
Okay.
That means if this number and this number are the same, then the answer would be this number.
That's okay. Got it. Yeah.
I'll just do a quick verification. Let's say 4 raised to the power log 16 to the base 4. Then if you calculate the power, it is actually 2, which gives you 16 itself. So this number comes as an answer.
Got it. Yeah.
Can we prove this?
Okay. Fine. So, okay, let's see. Okay, yeah. Let me see. So log.
Hint: this property comes from the very basic definition of log itself.
Yeah. Okay. So wait. So I did. Equals x and e to the power x. So log of. Okay. Then what's that gonna be? That's gonna be a and a to the power x equals. So it will be a to the power x. Okay, fine. I'll tell you what I did. So basically, for this log m base a, I simply equated log m base a to a variable, okay, like x, and I got a to the power x equals m.
Okay, and let me write what you did.
And then when I substituted a to the power x equals m in that, in the power log m base n, you get log a to the power x. So that becomes a to the power x, which we already said was m.
Yes, correct. So this x, you have to replace it back with this term.
Yeah.
And you got the answer. That's why it comes from the very basic definition of log.
Correct.
So if somebody asks you what is e to the power ln x, what is ln, by the way?
Ln, natural log.
Ln means to the base e. Lg means to the base 10. This is widely used in calculus. This is used in
Okay.
calculus.
Okay.
This is used in calculations.
Mm-hmm.
Okay. So this term will be x itself.
Yeah.
Okay. So what is e to the power ln x cube?
It'll be x cubed.
X cube itself. Okay.
Yeah.
Next property is a to the power log b to the base, let's say n,
Mm-hmm.
is same as b to the power log a to the base n. That means a and b can swap their positions and the value will not change.
Okay.
So I'll just do a quick verification of this. Let's say 2 to the power log, let's say 16 to the base of 4.
Yeah.
Okay. What is this answer? This is 2 to the power 2, correct?
Yeah, 2 to the power 4,
Which is going to 4. Okay. Even if you swap the positions, that means if you do 16 log 4 to the log 2 to the base 4, this becomes 16 to the power of half, which is again 4. So these two are equal.
Got it.
So this is just a quick verification. Can you prove this?
Okay. Log b log a to the base n. Okay. So I have to prove it, and how do I prove it exactly? So if I am going to equate that to x, I'm going to try it that way. Then n to the power x is going to give me b. Okay, so I equated log b to the base n to x. Okay, that gives n to the power x. That equals b. Okay, if that equals b, then okay, then what do I do? So I'll put that over b's power, x power x, b to the power x. Okay. Okay. So a log n base b equals b log. It gives b to the power x. Okay, and we know that b to the power x equals n to the power x. How is that going to help me? Let's see. N to the power x whole to the power x. Okay. So what am I doing? Yeah.
Should I help you out?
No. It's okay. Let me see. Wait. Actually, wait. No.
Try it out, no problem.
Okay. Who's b log This is going to be 1. Am I getting anywhere? I don't know if I'm getting anywhere. No, 1 second. Why? What do I do? M base. Actually, no, you can help me out.
Okay. See, you can say let log a to the power n be x and log b to the power n be y. Okay.
Okay.
So a is n to the power x, b is n to the power y.
Okay.
Yes or
Okay.
no?
Yeah.
Okay. Now, what is this property saying? This property is saying a to the power of log b to the base n. That means n to the power x to the power y.
Correct.
And b to the power log a to the base n means n to the power y to the power of x. They both are same. That's correct actually, because this is also n to the power xy and this is also
Yeah.
n to the power xy.
Oh, nice.
Okay. Yeah. So hence proved.
Okay, nice.
Okay. Well, now we are going to focus more on graphs. So we have seen the property. So I think the shifting and shifting of the graph to the left and the right, I've already told you, as well as up and down also.
Correct.
Have you also done changing the sign of x and y also?
Yeah, they're done. Reflection, right?
Reflection about x-axis when you change the sign of y. Reflection about y-axis when you change the sign of x.
Yeah.
So a quick question on this will take up. Let's say plot 3 minus y is log x plus 3 to the base of half.
X plus 3 to the base of half. Okay. So I have to give you like the general structure, right?
Yeah, I mean, roughly how would it look like? You just draw it on your notebook and let me know once you're done.
Okay.
Just do it step by step. Don't jump any step. Okay. So step number 1, you would have drawn the graph of log x to the base half.
Yeah, and I think it intersects the x-axis at 1, comma 0. I mean,
yeah, it'll come from top down like this.
Yeah. Okay, and then when it has to be x plus 3, then it shifts to the left by 3 units. So that means that it shifts minus 2. It becomes minus 2, comma 0 there.
Right. So second step is when you change your x with x plus 3, and as you rightly said, it is going to move 3 units to the left.
Yeah.
So the graph would now appear like this.
Then after that, to y 3 is added. If 3 is added, then
Achha, just a question, Arushi. What would be the asymptote here?
The asymptote. Oh, it shift. Over there it was x equals 0.
Yeah, here it was x equal to 0. Now it will be
x equals minus 3.
X equal to minus 3. Or you can say x plus 3 is equal to 0.
Yeah.
Okay. Now what do you want to do? Do you want to change the sign of y first, or do you want to do y plus 3 first?
Okay, I'll do y plus 3 first. I did that. So if I do y plus 3 first, then it'll shift down by 3 units.
Absolutely. So it'll shift
now
down.
Minus 2, comma minus 3.
So it'll shift down by 3 units. So it'll be coming like this.
Yeah, minus 2, comma minus 3 will be the point at which it cuts the y.
Yeah, where does it cut the x-axis?
Oh, it cuts the x-axis, or just it okay.
So tell me where it cuts the x-axis and y-axis both.
Okay. So initially it was cutting at 1, 0, but then it moved there, and now it moved like 3 units to the left, and now
That
it
you can
moved.
directly find from the equation itself. Let's say you want to know where it cuts the x-axis, put your y as 0.
Okay,
So
and
when you
just
do that, you get this. Okay?
Yeah.
And this is like saying half to the power 1/3, half to the power of 3
3.
minus 3. That is going to be 1/8 minus 3. This will be your coordinates, which is actually minus 23 by 8.
Okay,
So
just
it'll
find it
cut,
out that way. Okay, fine.
it'll cut at minus 23 by 8 comma 0.
Hmm.
So this is to know where it cuts the x-axis. Now,
Yeah.
how do I know where it cuts the y-axis?
It'd be -2, -3.
No, put x as 0 then.
Yeah.
Okay. So when you put x as 0, it becomes y plus 3 is equal to log 3 to the base of half. So y becomes log 3 to the base of half minus 3.
Yeah.
So this will be 0 comma log 3 to the base half minus 3 point.
Okay, got it.
Okay. Anyways, now what next I have to do? Remember, I have to get 3 minus y over here.
Correct.
So I will change my sign of y. That's my fourth step.
You'll change the sign of y, you'll reflect it across the x-axis.
Absolutely. We'll reflect it about the x-axis. So when you reflect it about the x-axis, how would the graph look like?
Okay, so you have that point -2, -3, and if you had to reflect that about the x-axis, then the y coordinate should stay the same, and it goes up. It would be 2, -3.
So this point will remain the same. So this will be reflected like this, and this entire part, as you can see, I'm running my pen on it. This entire part will be this part.
Correct.
So now this point will become 0 comma 3 minus log 3 to the base half.
Okay, yeah.
And this point still remains the same, 23 by 8 comma 0.
Yeah.
Let's check on GeoGebra whether we are getting the same result or not.
Okay.
Yeah, so our function was 3 minus y is equal to log 1 by 2 of
x plus 3.
x plus 3.
Okay.
Okay, there's slight graphic issue, that's why it's not showing complete. Yeah. Don't think that's stopping there, it's going down and down. Okay. So this point, if I try to find out, it will be minus 23 by 8. That's near about this, minus 2.86.
Mm-hmm.
It has gone up. There's slight graphic issues. Okay.
Okay.
Fine?
Yeah.
Now, let's talk about exponential graphs, exponential functions.
Okay.
Now, exponential functions are functions of the nature a to the power x, where a is a positive quantity not equal to 1.
Okay, fine. Yeah.
If you see this, it is almost the same property which log base also used to follow, right?
Yeah.
When I used to define log x to the base a, I used to say that a should be greater than 0 and a cannot be 1.
It cannot be 1, yeah.
So almost the same thing is followed here as well.
Yeah.
Okay. If your a is negative, what happens? For fractional powers, you'll start getting imaginary values of f of x.
Correct.
And if a is 1, it will actually become a straight line. So that is treated as a constant function, not an exponential function.
Okay.
Okay. Now, when I say a is greater than 1 and not equal to 0, it means there are two possibilities. One where your a is greater than 1, and other when your a is between 0 and 1.
Okay.
Correct?
Fine.
So for both these scenarios, the graph is slightly different. Okay.
Mm-hmm.
So I'll draw the graph for both of them separately. Let's take a case where a is greater than 1. Tell me any value of a greater than 1.
Like 2.
2.
Some.
So
Yeah.
let's say I want to draw the graph of 2 to the power of x.
Yeah.
Now as you can see, 2 to the power x, if you take value of x as 0, y will be 1.
Correct.
So the function will be cutting the y-axis at 0, 1.
Got it.
Correct. As you increase the value of x as 1, you'll get a value of 2.
Yeah.
For 2, you'll get a value of 4.
Yeah.
For 3, you'll get a value of 8 like that. Okay.
Correct.
For minus 1, you'll get a half.
Yeah. And minus 2, you get
1/4 like that. So if you connect these dots, you would realize that the graph of this function would look like this.
Yeah, it increases.
Like this.
Got it.
And remember here, your x-axis, that is y equal to 0, would be acting like an asymptote.
Okay, fine.
That means an exponential function will never ever touch the y-axis, and hence it will never go negative as well. Right?
Okay, yeah.
So an exponential function can never be negative. Remember that.
Yeah.
So if somebody says solve this equation, 3 to the power x is equal to minus 2, that's not possible.
Correct.
Because it can never be negative.
Mm-hmm.
If at all you have to solve 3 to the power x is equal to 0, then x has to be negative infinity. That's also very difficult to achieve.
Yeah.
Okay.
Okay. Mm.
What about when your a is between 0 to 1? Acha, in this also I'll ask you some questions, just like I asked you in log. What happens if I ask you y is equal to 4 to the power x?
Okay, that would be y equals 2 to the power 2x, right?
That means will it be more bent like this, or will it be less bent like this? So is the answer the white graph or the green graph?
Okay, okay. So wait. So this would be the same thing as y equals 2 to the power 2x. So if you put in a value of x, say 1, should give you like okay so here at x equals 0, it was yeah, on the y-axis it cut at, okay, all of them it cuts at 1.
Yeah.
So if I put x as 1, for example, then y will be 4. But if I put x for the first one, if I put x as 1, then it was 2. Right? So for here, over here, when it's 1, it's 4. And over there, when it was 1, it was 2. So, for example, this is x to the power 1. Okay, yeah.
So you're right. So it is 2 for this, and it should be 4 for the other one, right?
The white one.
So it has to be the white one. It has to be the white one. And another thing that I would like to highlight over here, I think I didn't tell you before.
Mm-hmm.
If you have the graph of this known to you, correct? And if you want to draw the graph of something like, let's say, kx, where k is greater than 1, okay, then this graph would be the graph of this more bent towards y-axis,
Okay, fine. Okay, so if it's like y equals f of x, and
I'll give you an example, very simple example to relate. Let's say y is equal to x.
Okay.
We know the graph of this is a straight line like this.
Yeah.
Correct. And if I ask you y is equal to 4x,
okay,
then the graph of this will be more bent towards the y-axis. It will become like this.
Okay, fine.
So as to say that it will shrink along the y-axis.
Okay.
So when you were doing this analysis, that 4 to the power x was 2 to the power of 2x, then I got reminded of this, because here now you're changing your x with kx, where k is greater than 1. So your graph will shrink more towards y-axis, so it will bend like the white one.
Okay, got it. Right? Understood.
Yeah. Achha. So higher the value of the base, the more bending it will have towards the y-axis.
Yeah.
Now let's go on to the base being between 0 to 1. So let's choose half to the power x. Now, given that you know y equal to 2 to the power x graph, can you produce the graph of y is equal to half to the power x without replotting it?
Yeah, without replotting it, if you know the graph of y equals 2 to the power x. Oh, okay. When we did the logarithms graph, it was the mirror image of this. So would that also be the case here?
See here, Arushi, half to the power x is as good as 2 to the power negative x. So
yeah,
what are you doing?
okay.
You are changing the sign of x.
Yeah.
So if you're changing the sign of x means you will reflect this graph about y-axis.
Yeah.
So won't the graph appear like this then?
Oh yeah, correct. Got it. Yeah.
Again, it will cut it at the same place, 0, comma 1. So this will be the graph of half to the power of x.
Okay, got it.
Okay. What will happen if I ask you the graph of 1/4 to the power of x? Will it bend more? Will it be like this?
Y equals 2 to the power minus 2x.
Yeah, or will it be like the green one?
It should bend more towards the y-axis, right?
Absolutely. Now you have got the trick.
Yeah.
So this is as good as saying y is equal to 2 to the power of minus 2x. 2x. So you are replacing your x with 2x. That means bending towards y-axis or shrinking towards y-axis should happen.
Okay.
Okay.
Yeah.
Now, another important fact is the relation between a to the power x and log x to the base a. These two graphs are actually related. How they're related? Let me show you on a diagram how they're related. You will be able to identify.
Okay.
If I choose a common base, let's say I choose a base as 2. Okay. Then I draw y is equal to 2 to the power x. Let me draw it with a yellow pen. So y is equal to 2 to the power x will be like this.
Okay.
Okay. And let me draw y is equal to log x to the base of 2. So that graph will be like this.
Oh.
Okay. Do you see some kind of similarity between these two graphs?
Yeah, they do look like mirror images of each other.
About which line?
Y equals x.
Absolutely correct. So this is 0, comma 1, then this is 1, comma 0. And as you rightly identified, they are mirror images about the line y equal to x.
Yeah.
Okay, the mirror images about this line y equal to x. Such functions which are mirror images of each other about y equal to x are called inverses of each other.
Yeah, I've done that. Images about.
Okay.
Yeah.
So if you want to find inverse of any function, you just have to swap their positions of x and y.
Yeah.
So if I swap the position of x and y in this, you'll see that I'll end up getting this. Let's try this out. So x is log y to the base 2. That means y is equal to 2 to the power x. So I got this function.
Okay, yeah.
Okay. Here also you swap the position of x and y, you'll end up getting this function. So let's see. X is equal to 2 to the power y. So y is equal to log x to the base 2. So we got this function back. Okay.
Yeah.
So in inverse case, you can get the other function just by swapping the position of x and y, which brings me to a very important rule that if you replace or if you swap, if x and y are swapped, the graph gets reflected about y equal to x line.
Gets reflected
About the y equal to x line.
Okay.
Is that fine?
Yeah. Okay, yeah.
So with this rule in mind, can we plot the graph of x equal to y square minus 4y plus 3?
Okay, yeah.
Try it out.
So x equal to y square minus 4y plus 3. So if x and y are swapped, the graph gets reflected about the y equals x axis, x line. Sorry. Okay. So so first if I swap x and y here, then it'll be x square minus 4x plus 3. Then I need to first plot this and then reflect it about the y equals x line.
So just execute it and let's check whether we get the right answer.
So if I have to plot this, then what do I do?
Just try this. Meanwhile, I'll have some water and be back.
Yeah, sure.
Yeah, done.
Okay, so I just drew a rough sketch of the y equals x square minus 4x plus 3 graph. So it has like roots at 1 and 3, and then vertex is at 2 comma minus 1.
Okay.
Then I have to reflect it about y equals x.
And that's the problem, right? Imagining the reflection is slightly problematic for many of us.
So so basically, I think that you would have to just, for the main points, would you just swap x and y? For example, for the inverse, the vertex would probably be at x equals minus 1 and y equals 2, maybe like that. Do you go that way?
Okay, let's try it out. See, first of all, you would have drawn this graph because this is easy to plot, correct?
Yes.
So when you plot this, as you rightly pointed out, this is factorizable. And even if it is not factorizable, we know how to complete the square and do it, right?
Yeah.
So let me try that. So this is x minus 2 whole square minus 1, correct?
Yeah.
So it's y plus 1 is equal to x minus 2 square, which clearly indicates that the y equal to x square parabola has to be shifted 2 units to the right,
yeah,
and 1 units down, right? So it will appear like this.
Correct.
So this point, that is the vertex, which we call it, will be 2 comma minus 1.
Yeah.
Now, when you have to swap your x with y and y with x, you need to actually imagine the reflection of this graph about y equal to x line, which actually is difficult for many of us, including me when I was preparing as a 12th grader. So what I did, I devised a mechanism to do that.
Okay.
And I shared that with you. You'll not find that in any book.
Okay.
So what I did first, I reflected this graph about the x-axis, which is quite easy to do because reflection about x-axis is the easiest you can do in any graph.
Yeah.
Is that fine?
Got it.
So
Got it.
first step is what I did. I reflected it about the x-axis.
Okay.
Correct. Right? And then I drew this on a piece of paper and I just turned the paper 90-degree anti-clockwise.
Okay.
90-degree anti-clockwise.
Okay.
So if you turn the paper 90-degree anti-clockwise, you end up getting the desired graph. So basically, the graph of it would look like this. Right? You can try plotting it on a piece of paper and just turn the piece of paper 90-degree anti-clockwise.
Okay.
So this point will now become the vertex.
Okay. 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 So, but then, okay. So is the point going to be the same thing as -1, 2?
Yeah, -1, 2. Basically, these two will swap their positions.
Yeah. So I mean, if you need to reflect about that point, is it possible to simply like swap the positions of x and y for all the points and do it? Will that
But that is actually that's actually what should be done. But it takes a lot of time swapping all the points.
Okay,
Okay,
fine. So this way is easier.
Yeah, so this is the mechanism which I devised. Let's check whether we get the same answer when you plot it on GeoGebra.
Okay.
So we had the graph as x is equal to y square minus 4y plus 3. You see that?
Oh yeah. Got it.
Yeah.
It's like the parabola sort of thing.
Yeah. So this point is the vertex over here, which is at -1, 2.
Okay.
Okay, now how does this work? That time when I was doing it, I could not figure it out, but somehow this trick was working for me in all the cases.
Okay.
But later on, when I was in my graduation, then I realized it actually comes all from the transformation of graphs. So when I reflected it about the x-axis, basically what I'm doing is, let's say this is the graph which I want to reflect about y equal to x line. So first step was when I did its reflection about x-axis, I did minus y is equal to f of x. Correct.
Yeah.
This is what I obtained from step number 1.
Correct.
Okay. Now when I rotated it 90-degree anti-clockwise, I realized that I'm making the x-axis as the y-axis and I'm making y-axis as the negative x-axis. Correct.
Oh.
So I'm making x-axis as the y-axis and I'm making y as the negative x-axis. That's the meaning of rotating 90 degrees anti-clockwise. So in this graph, if you replace your y with negative x and x with y, we automatically see that our x and y get swapped.
Okay.
And that's why my methodology actually worked in all the cases.
Oh, nice.
Okay. So this is something which you'll not find in books. And many cases in especially like chapters inverse trigonometry and all, you would be required to do the reflection about y equal to x line, and in those chapters this method will be very, very helpful. Okay. Now
how do I visualize 90-degree anti-clockwise?
For that I would suggest you do it on a very small piece of paper. Just draw a graph like this. Okay, and just turn the paper 90-degree like this. When you turn the paper,
I use a tracing paper like thing maybe.
I mean, I use my eraser actually, to be very frank. On the eraser, I drew a rough diagram and then I just tilted it and I retraced it back on my answer script.
Oh, okay.
Acha, can you suggest me an alternate way to do this?
An alternative way to do this?
That means first I reflected about x-axis and rotated it 90-degree anti-clockwise. You can also do it by another way also. Can you suggest me that, if at all you can think of? Of course, one way is imagining the reflection about y equal to x, but assuming that is difficult for me to do.
Yeah.
Any other simpler way?
Any other similar way to do it? Okay, fine. One is that you could simply swap them, but the other way, what would it be? Okay, if I first reflected it across the y-axis, would I get the same thing? No, if I reflected about the y-axis, then it would bring me to y equals negative x. Then
you're on the right track. Good. Go ahead.
Then I will rotate it 90-degree clockwise.
Absolutely brilliant. Awesome. Well, you're the first person who could answer this. So first reflected about y-axis.
Yeah.
About y-axis. When you're doing that, you're actually changing the sign of x. So you're doing this actually.
Okay.
Okay. And then when you said reflected clockwise 90 degree, clockwise 90 degree, that means you're making y as x and x as minus y, right?
Yeah.
So y as x and x as minus y. So basically you end up swapping the position of x and y.
Okay.
So these two positions got swapped.
Understood.
We'll take few more questions on this. Plot x is equal to e to the power of 3 minus y.
Okay, I have a question. When you do reflect it like that, right? You don't get a function anymore, right? It does not become a function because it doesn't pass the test.
Yes. In the previous case, it is no longer a function. That's correct. Good observation. Yeah.
Yeah, that's not a relation.
Yeah, that would be a relation, but not a function because it doesn't satisfy the vertical line test.
Got it. So I have to plot x equals e to the power 3 minus y. So the first thing I'm going to do is going to be to swap them. Power 3 minus x. So this is the same thing as y equals e to the power minus x plus 3. Okay. So if you have e to the y equals e to the power x, that's going to be like the bone sort of structure. Then I would plot it. Okay. So when x is 0, y is e. What is the value of e? Wait. When x is 0, y is not e. What am I saying? When x is 0, y is 1. Yeah. So it will cut the y-axis. The original graph will cut the y-axis at y equals 1. Okay. We'll go like that. And when we cut the x-axis, x equals 0. So it'll never. Okay. Yeah. Whenever you have this exponential graph like e to the power x, it's never gonna touch the x-axis, right? Whenever you have like e to the power x, just e to the power x.
E to the power x will never touch the x-axis. That's right.
Yeah. Okay. So now I have y equals e to the power minus x plus 3. So basically, I'm gonna move it three units to the left. Okay. So if I move it 3 units to the left, my point on the y-axis, which was 0, 1, will be. If I move it 3 units to the left, it will be minus 3, 1. Okay, and then I have to reflect this across the minus 3, 1. Then I have to reflect this across y equals minus x. So this will be reflected across the y-axis. If it is reflected across the y-axis, then it would be 3, 1. Okay. Now I'm done with that. But now I have to reflect this across x equals y-axis. So I have that drawn there. Now if I have to reflect this across x equals y-axis, then that point is basically going to be at 1, 3. Right?
So are you done with the graph?
Yeah.
Okay. The first thing that you would like to do is plot this graph, correct?
Yeah.
So for this, we have to start with y is equal to e to the power x. So the graph would look like this.
Yeah.
Since e is greater than 1, it will follow. E is actually 2.71828 like that. It's an irrational number just like pi.
Yeah. Okay.
So it's greater than 1, so it has to be of this shape. Now, what do you want to do next? Do you want to change your x with x plus 3 or do you want to change your x with minus x?
What I first did was I simply shifted the graph like 3 units to the left. So I did x plus 3 first.
Okay. Never mind, we'll do that. So if we do that, it gets shifted 3 units to the left. If it gets 3 units shifted 3 units to the left, the graph will appear like this.
Yeah.
Okay. I think it'll cut at a higher value, right? Because this is shifting to the left, right? So a higher point will come and cut it. So
yeah.
at 0, it will be at higher position. Yeah.
Hmm.
Because when you put x as 0, y will be e cube. E cube will be almost like 8ish kind of figure. 8ish or 9ish. Yeah. Yeah. So this will be 0 comma e cube. Now, next step is changing x with minus x.
Yeah, it will reflect it across y-axis.
When we reflect it about the y-axis. So that will become something like this. Okay.
Okay.
And then we have to swap the position of x and y. So we have to swap the position of x and y. That means we have to imagine the reflection of this graph about y equal to x line. And again, as I already discussed with you, you can follow the approach which I told you. So first reflect it about x-axis, which is like this. Okay. And then rotate it 90 degree anti-clockwise direction. So how will it appear?
It will be just wait.
It will appear like this.
Correct.
Okay.
Yeah, got it.
This point would be e cube comma 0.
Okay, fine. Yeah, because you should swap the points. That's all.
Yes.
Understood.
Okay. Let's see on GeoGebra itself. So we have x is equal to e to the power of 3
minus 1.
You see that?
Yeah. Oh, okay. Correct.
E cube is almost E cube is almost near to 22, I think, because 2.718 to the power of 3 will be approximately lesser than 27.
Yeah. So that's why. Okay, got it.
So that's what we have shown over here. Yeah. Try this one. X is log to the base of 2. Let's say 5 minus 3y.
5 minus 3y.
Yeah.
Okay. 1 second. So the relation is y equals e to the power x equals, so y equals e to the power x is basically the reciprocal of y equals log x to the base a. Does that have any relation here? Y equals e to the power x, then y equals log x to the base a. Okay, anyway, never mind. First, I will swap it. So y equals log 2 5 minus 3x. Okay, now I've got this. Fine. So if I have so first I'm going to plot log x to the base 2. I do log out x to the base 2, then what would happen? Okay, how would my graph be? My graph would sort of be like this. Okay, so it would be like that. It would cut the x-axis at x equals 1. Okay, now that's done. Now, let's see. Now it has to be minus 3x plus 5. Okay. Now minus 3x. Okay, first negative of that would be reflection across y-axis. Okay, reflection across y-axis should be like this. Okay, and this reflection across y-axis, then it will move to minus 1 comma 0. Okay. Now minus 3, right? Minus 3 meaning that it's going to bend more. Minus 3 meaning I'll bend more towards the y-axis than usual. Okay. Okay, so basically my that point will be at minus 1 by 3 comma 0. Okay, then after that, this graph is basically moved like 5 units to the left. So if it is moved 5 units to the left, then it would be like minus 5 minus 1 by 3. Okay, which is minus 5.33. Move like here, to shift it there. Then, yeah, that's it. Okay, after that, I have to just reflect it across the y equals x-axis. Okay, I reflect it across y equals x-axis. Now it will be, it'll simply swap, and it'll be like 0, comma, 1 by 3. Okay, done.
Done? Okay, chalo, let's discuss this. So first of all, we would start with the graph of log x to the base 2, which is going to be like this.
Yeah.
Then what I'm going to do next, I'm going to change my x with x plus 5, or you can say 5 plus x. Okay.
Yeah.
That means I'm shifting this to the left.
By 5 units.
By 5 units. So my graph would appear like this. I'm going a miniature version. So this point will now cut at minus 4 comma 0. Okay. And this will become the asymptote. That's x equal to minus 5 will become the asymptote. Okay. Next, what I'm going to do is I'm going to change x with minus x. So that's going to make it 5 minus x, means I'm reflecting the graph about y-axis.
Yeah.
So if I do that, my graph would appear like this. My graph will appear like this. Okay. So now this point will become 4 comma 0 for me.
Yeah.
And this will be the asymptote.
Okay.
Now I'm going to make x as 3x, which means shrinking the graph more towards the y-axis. So basically, the points will not change, but this graph will shrink like this.
Oh, the point won't change, okay.
This point won't change because you're shrinking about y-axis, but this point will become 4 by 3 comma, 4 by 3 comma 0.
Okay.
Because it is getting 1/3 shrink. This means 1/3 shrink is happening.
Yeah, okay.
Getting the point?
Yeah.
And you can also check that when you put x as 4 by 3, your y will become 0.
Okay, got it.
Why? Because log of 5 minus 4 by 3 into 3 will be log of 1, and log of 1 to any base is going to be 0.
Okay.
Which clearly indicates it is passing through 4 by 3 comma 0.
Okay.
Now, I have to swap the position of x and y.
Okay.
So I have to swap the position of x and y, means the fourth step is I have to take the reflection of this graph about y equal to x line. Okay. So that would become First, what did you do? First, what should we do? Reflect it about the x-axis. So that will look like this. Okay. And then rotate it 90-degree anti-clockwise. So it will appear like this. Now this point will become 0, 4 by 3. Correct?
Yeah, okay, got it.
Yeah.
Got it.
So this is the final answer.
Okay, fine.
Okay. Now plot this one. Plot this one. Let's say x is equal to 2 minus 3 minus y to the power of 5. Done?
Wait 1 second.
Yeah.
So suppose I simply swap it, then simply take the x to the power 5 graph and then add 3 to it. So x to the power 5 would be so x to the power 5 cuts the x-axis at the origin, right?
X to the power 5 would be like this. It'll be more
flat
like this.
Of the x cube one. Correct. Okay. So
X cube is more like this.
good. Okay. So x to the power 5. So first take y equals x to the power 5. That is at 0, 0. Okay, and then to that you're adding 3. So it's going to shift to the left by 3 units. It's going to be
0. 2 बजे है शायद एग्जैक्ट टाइम हम भेज देते हैं
and then I shifted y equals x. Need to go on. Okay, got it. Done. Hello?
Yes. Done?
Yeah, done.
Okay. So let's discuss this. It'll be first y is equal to 2 minus 3 minus x to the power of 5.
Yeah.
Okay. So we can write this as first of all, we'll start with x to the power 5 graph. Okay.
Yeah.
X to the power 5 we have already discussed. It's going to be like this.
Okay.
Now, first thing we'll do is we'll first rephrase it as y minus 2 is equal to negative 3 minus x to the power 5, which is as good as saying y minus 2 is x minus 3 to the power 5.
Okay. Yeah. So what I did was I shifted the negative sign to the y part so I could reflect it. I did went that way.
So in this case, you will have to shift it 3 units to the right and 2 units up.
Correct.
So it will be like this. Just be careful. Just be careful whether it's passing through origin or not. Origin will not pass. When x is 0, y will be negative number. So it will pass like this.
Yeah.
Okay. So this point will be 2, 3. Correct?
Yeah.
Now, next what you have to do is we have to swap the position of x and y.
Yeah.
Correct? So to swap the position of x and y means we have to take the reflection of this about y equal to x line.
Correct.
Correct. So for that we first have to draw its mirror image like this. So the mirror image would be like this about x-axis. and then rotate it 90-degree anti-clockwise.
Yeah.
So it will appear like this. Okay.
Hmm.
So this point will come to -2 comma -3. Sorry,
It should be 3 comma 2, right?
just yeah. I think this point, this point will. You are actually trying to turn it. This graph has a bend actually. That's why it is slightly difficult to imagine the reflection.
Yeah.
Oh, you are reflecting this about x-axis, right? So this is the graph. This graph is not the reflection. I'll redraw it. The reflection would be like this. Yeah. This point will become 2 comma -3.
Oh.
Okay.
Oh, okay. But
So yeah.
isn't it supposed to be 3 comma? Wait.
No, I'm now
We
rotating.
understand. Correct.
I'm now rotating it 90 degrees anti-clockwise.
Yeah.
So if I rotate it 90-degree anti-clockwise, it will now appear like this. This will be the
Okay.
3 comma 2.
Okay. And for
Okay.
this, actually, I got the answers 2 comma 3. I don't know where I went wrong. Actually, can I tell you what I did?
Mm-hmm.
I got the answers 2 comma 3, and I don't know where I went wrong. So can I tell you what I did, and can you tell me what I did wrong? So first I just swapped those two.
Mm-hmm.
Then after that, I brought 2 to that side, so it became y minus 2 equals minus 3, minus of 3 minus x to the power 5. Okay.
Mm-hmm.
Then I the negative sign that was on that side, I basically multiplied y minus 2 with the negative sign, so you get minus y plus 2 equals 3 minus x to the power 5.
Mm-hmm.
So here, okay, so then what I did was, first x and y I constructed the graph, 0 comma 0. Then I shifted it 3 units to the left. Okay, I shifted 3 units to the left by it, so it became minus 3 comma 0. When I shifted 3 units to the left.
It actually looks like this actually.
Yeah.
Yeah, because this part, when you turn it 90-degree, it will be like this. So this face will be this face,
Mm-hmm.
and this face will be like this.
Okay.
Are you getting such kind of a graph?
No, I don't know. It's just I'm getting that point is 2 comma 3. I'm getting the reflected point is 2 comma 3.
Mm-hmm.
I don't know. Wait, so okay, so I did that and I moved it like 3 units to the left.
Mm-hmm.
Then after that, what did I do? Okay.
But idea is clear, right? Idea is clear how it works.
Yeah.
Yeah. Okay. So we'll try one more. Plot. Plot x is equal to y minus 1 whole cube plus 3.
Okay. And I have a question, like whenever you're doing this, you can do those steps in any order, right? You'll still get the same answer. Hello? Hello?
Done?
Yeah, almost. And I have a question.
Yes.
So whenever you're doing this, you can do like the steps in any order, right? You still get the same answer.
Yeah.
Yeah. Okay. Fine, I'm done.
So first of all, we'll do y is equal to x minus 1 whole cube plus 3.
Yeah.
So it's as good as saying y minus 3 is x minus 1 whole cube.
Yeah.
So, yeah. So the graph of x cube will get shifted 1 unit to the right and 3 units up.
Yeah.
Right? So 1 unit to the right and 3 units up means
How much?
the graph will come like this. Yeah?
Yeah.
And now I have to reflect this graph about y equal to x line.
Okay.
Okay? So it's
3, 1.
Yeah, so its reflection would be like this. So this point will become 3, 1. So it'll be like this. Is that fine?
Yeah.
This is how you got it?
Yeah, got it. 3, 1.
Now, next thing that we're going to discuss is functions which are of the nature 1 by x, 1 by x square, 1 by x cube, like that.
Okay.
So let's say if I ask you plot the graph of y is equal to 1 by x.
Yeah.
Okay. So initially, if somebody doesn't know the graph, he will choose some points of x and then plot it.
Yeah.
Now, if you choose a value of x which is very, very small positive number, let's say x is 0.00000001, what would be the value of y be?
Well, value y. Okay. So it'll be larger.
It'll be a very large value. It will be almost
Yeah.
plus infinity.
Correct.
So the graph will come from plus infinity like this.
Oh, that way.
And as you keep increasing the value of x, it will fall down.
Okay.
And as x goes to plus infinity, y value will almost die to 0 but never become 0.
Yeah.
Okay? In a similar way, if your x is slightly negative value, let's say negative 0.00000001, then y will almost go to negative infinity, correct?
Yeah.
So in the neighborhood here, it will go to negative infinity, so it will come back like this.
Okay.
Okay, so it will be a graph like this. So both the arms of this graph are these two arms.
Yeah.
Okay, this graph is called a rectangular hyperbola.
Rectangular hyperbola.
Yeah. When we do the chapter in conic sections, we'll study more about rectangular hyperbola. You'll find these graphs also in physics in isothermal curves.
Okay.
Isothermal curves. The graph of P versus T, PV curve, PV graph. Okay.
Yeah.
Now, all the transformation that we have learned so far would be applicable to this. Remember, it has two asymptotes. One is a horizontal asymptote.
One's vertical.
Yes. This equation is y is equal to 0, and one is vertical, x is equal to 0. Okay.
Yeah.
Now plot y is equal to 1 by x minus 3 graph.
Okay. Okay, so if it is y equals 1 by x minus, then in which
पता नहीं, I have a class right now. Decide करता हूँ. देखता हूँ. So you're changing x with x minus 3, right?
Yeah, so 3 units to the right.
Right. So how will it look like? Now this vertical asymptote will shift 3 units to the right. So think as if now your vertical asymptote is like this. It has come x equal to 3.
Yeah.
Okay, now this has become x equal to 3 line. So your graph will be like this.
Okay. Yeah.
Okay.
Okay. Fine.
Let's see that on GeoGebra. So this was the graph of y is equal to 1 by x. Okay.
Yeah.
Expand it. So this is the graph of 1 by x minus 6. As you can see, it has shifted 3 units to the right. You see that?
Yeah.
So I'll just show you the asymptote x equal to 3. Okay?
Okay. Fine.
If I ask you to plot the graph for
Oh,
y,
so it's basically tending towards x equals 3, but it's never x equals 3, because if it does reach x equals 3, then it becomes not defined.
when it is infinity.
Yeah.
So asymptote is what? Asymptote is a line which touches the curve at infinity.
Okay. Fine.
Okay?
Yeah.
Now plot this graph.
Okay. That's just, you have to just move this like 1 unit down.
Absolutely. So basically we have to now make the graph like this. Okay? This line is x equal to 3. This line is y is equal to minus 1.
Okay. Fine.
Understood how it works? Next is functions of this type, 1 by x squared. Again, the story is same, but in this case, a slight difference would be when you're very close to 0, let's say on the positive side of 0, y will become infinitely big. And so would be the case when you're left to 0. So again, y will become infinitely big. That means the graph will come from infinity and go like this on both the sides of the graph.
Okay.
It's very obvious that this curve will be symmetrical about y-axis because the power on x is even actually.
Okay.
So even if you do y is equal to 1 by negative x whole square, the graph doesn't change. So reflecting about y-axis doesn't change the figure. So such a thing will only happen when the function is already symmetrical about y-axis.
Okay.
Okay. So here it has again two asymptotes. One is your x is equal to 0 and other is y equal to 0. So this is a horizontal, this is a vertical. Okay. So plot y is equal to 1 by x plus 2 whole square plus 3.
Y equals 1 by x plus 2 whole square plus 3. Okay. So here, the asymptote for y will go will go move up by 3 units. So will be like at y equals 3, there'll be an asymptote. Then also there'll be an asymptote at let's say wait, yeah, x equals -2.
Mm-hmm. So what would be the final shape of the graph be? So
Yeah.
it's always advisable that you make the asymptotes first.
Okay.
So horizontal asymptote will be y equal to 3. Vertical asymptote will be x equal to -2, correct?
Yeah.
So you just have to shape the graph near about these two lines. So basically it will be this. Understood?
Yeah.
So both the arms will move simultaneously. Many people do a mistake, they just move one of the arms or the other arm. Both have to move together.
Okay.
Okay. Now there's not much of a difference in the graph of 1 by x and 1 by x cube. It's just that the steepness of these two arms will change.
Okay.
So can you tell me how would the steepness change? Let's say this is the graph of 1 by x. Then how would be the graph of 1 by x cube be? Let's say this is point 1, this is point -1.
Okay. Okay. So when x equals okay, so when x equals -1, when x equals -1, y will also be -1. Okay, so it'll also be -1, so it'll be here, and then when x equals 1, y will also be 1, so it'll come there. Okay, then when x equals 2, it'll be 1 by 8. Okay, when x equals 2, it'll be 1 by 8. So what will that be? Yeah, that'll be like much smaller, be like 0.125.
Okay, just a question. When x belongs to this interval, -1 to 1, which is greater, 1 by x or 1 by x cube?
Okay, wait, when 1 by x will be 1, and wait, so when x equals -1, 1 by x will be -1.
They will be same at 1 and -1, but let's say somewhere in between, let's say 0.5 if you take.
Okay.
Which will be greater, 1 by x or 1 by x cube?
Okay, so 1 by 0.5 cube is 8, but 1 by 0.5, okay, it will be 1 by x cube.
Correct. So the graph will be 1 by x cube graph will be higher in this zone. So in this zone, the graph of 1 by x cube will be higher. But the moment you cross 1, let's say you become a 2, the graph will fall down like this.
Okay.
Correct.
When greater than 1 or lesser than -1, 1 by x is greater.
Yes. So basically here, the same story will be repeated here also. Lesser, 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 and here it will be more.
Okay.
Okay. I'll show you both the graphs on the same. So y is equal to 1 by x and y is equal to 1 by x cube. You see that change? The red graph is the graph of 1 by x cube. Green graph is the graph of 1 by x.
Okay.
So after this point 1, you can see that red graph is below the green graph.
Yeah.
And between -1 to 1 or between 0 to 1, you can say the red graph is higher than the green graph.
Okay, got it. Yeah.
Okay. So what will happen if I do 1 by x to the power 5? Can you predict what will happen?
Yeah. Okay. So it was between -1 and 1. 1 by x cube was greater than 1 by x. So basically, 1 by x to the power 5 will be greater than 1 by x cubed within the same domain, like between x less than 1 and greater than minus 1. And after, when x is greater than 1, when x is less than minus 1, 1 by x cubed will be greater.
So do you see this happening?
Yeah. Oh, yeah.
Okay.
Okay.
So basically what is happening is the power of x, if you keep on increasing by odd numbers, for example 1 to the power x to the power 5, on this side it will become higher, but on the other side it will become lower.
Okay.
So it will become more like this. Getting the point?
Got it. And when it's like an even number, then
Okay. Yeah. Now I'll come to that. What if I have y is equal to 1 by x to the power 4?
okay. Fine. I'll check first between minus 1 and 1. If I check between, and then y equals 1 by x squared. Okay. So if I check between minus 1 and 1, for example, if I take 0.5 as usual, then 0.5 to the power 4 would be, okay, that would give you 16. But then 1 by 0.5 squared, that gives me 4. Okay, so between minus 1 and 1, between minus 1 and 1, 1 by x to the power 4 is greater than 1 by x squared. But then when x is greater than 1, or when x is lesser than minus 1, then 1 by x squared would be greater than 1 by x to the power 4.
Yes, absolutely. So this is how the graph of 1 by x. This is yellow one is the graph of y is equal to 1 by x to the power 4.
Yeah.
White one is the graph of y is equal to 1 by x squared.
Yeah.
Okay. So again, all the shifting concepts will be equally valid here as well. So let's draw the graph of y is equal to 3 minus y is equal to 1 by 2 minus x to the power of 5.
Okay. 3 minus y equals 1 by 2 minus x to the power 5. Okay. So this is going to get shifted, the asymptote is going to get shifted 2 units to the left.
See, you can also rephrase it as y minus 3 is equal to 1 by x minus 2 to the power 5.
Okay, yeah. Makes it easier.
Yeah.
Anyway, it shifts 2 units to the left. To the left. The asymptote shifts there, and then y shifts 3 units up. 3 units up. Yeah. Okay. Okay, done.
Done?
Yeah.
So let's discuss this. So x to the power 5 will be, yeah, first of all, the vertical and the horizontal asymptote. So x minus 2 means the vertical asymptote will shift at x equal to 2.
Yeah.
And y minus 3 means vertical asymptote will shift to y equal to 3.
Okay.
Okay. And your graph will be positioned like this. Understood?
Got it.
Yeah. Great. Now I'm going to talk about special functions. So we have already seen polynomial functions of various degrees, quadratic, cubic. We also saw reciprocal functions 1 by x, 1 by x square, etc. We also saw log function, exponential function. Now time has come that I introduce some special functions to you, which will be asked in your class 11th,
Mm-hmm.
and the first one being the mod function, which we call as the modulus function.
Okay.
Okay. What is modulus function? The simplest of all modulus function is mod of x. Right? What is the
Yeah.
meaning of mod? Mod means absolute value. This function gives the absolute value of the input. So
Okay.
if I say mod of minus 3.2, it will give you 3.2.
Yeah.
Okay. So this function returns the absolute value of x.
Okay.
That means without the sign into consideration. That's the magnitude part.
Okay.
So if I say 3.2 modulus, it will just return 3.2 to you. Okay.
Mm-hmm.
So if I have to define this function in a simpler way without using these parallel lines, I would define this function like this. This function would return x to you if x is already a positive quantity. Correct?
Yeah.
For example, when I put 3.2, it returned 3.2 to me because 3.2 was already a positive quantity.
Yeah.
But when it is a negative quantity, this will return negative x to you.
Correct.
So when x is already a negative quantity, it will return negative of the x value. That is negative of negative 3.2, which is 3.2. Okay.
Yeah.
So if I have to plot such a function on the graph,
Mm-hmm.
I will plot it like this. In the interval 0 to infinity, it will follow the line y equal to x.
Okay.
Which is going to be a line like this.
Yeah.
Okay, but I cannot go down because it is only valid for x greater than equal to 0.
Okay. Yeah.
Now for negative value, that means from 0 to negative infinity, I will plot y equal to negative x.
Okay.
That would be like this. Okay. So it will look like a V. And remember, these angles will be 45, 45, 45, 45.
Oh.
Okay.
Okay. Right.
Such functions are also given a name of piecewise functions. What is a piecewise function? Piecewise function is a function which is defined in pieces. Right? So most of the function that human beings themselves are piecewise functions. We behave differently in different situations. Correct?
Correct.
So it's like this is the situation and this is how it will behave.
Okay.
This is the situation and this is how it will behave. So when your x is greater than equal to 0, it will behave like a line y equal to x.
Yeah.
And when x is less than 0, it will behave like the line y equal to negative x.
So when it's greater than 0, when x is greater than or equal to 0, it'll behave as y equals x, and otherwise it'll behave as y equals minus x.
Minus x, absolutely. Okay. And again, all the concepts that we have talked about, transformations, will be valid on this as well. So if I ask you, plot the graph of y is equal to mod of x minus 2.
Y equals mod of x minus 2. Okay, if it's mod of x minus 2, then it will shift 2 units to the right. So the that the point where it touches the x-axis will be at x equals 2.
Okay, so what will happen to this v?
Huh?
What will happen to this v graph?
It'll simply shift to the right by 2 units.
Yes, it will shift to the right by 2 units, so it will be like this.
Yeah.
Okay, so this point will become x equal to 2.
Yeah, so this will be y equals, the right hand part of the graph will be y equals x minus 2, and the left hand part will be y equals minus x plus 2.
Absolutely. This will be y is equal to minus of x minus 2, you can say, or you can also say 2 minus x.
Okay.
So in light of this, you can actually redefine. Redefine means writing without mod. The way I've written over here, this is called redefining the function.
Yeah.
Redefining means defining the function without mod into place.
Okay.
So mod of x minus 2 is defined as x minus 2 when x is greater than equal to 2, and is defined as 2 minus x when x is less than 2.
Okay.
Okay. In general, Mod of x minus a is redefined as x minus a when x is greater than a, greater than equal to a, and a minus x when x is less than a.
Okay.
Okay, so I'll give you a quick question over here. There's a function f of x which is made up of these three functions: addition of mod x plus 1, mod x minus 2, mod x minus 3. Okay, question is redefine f of x.
Redefine f of x.
Yeah.
So if I need to do that, then okay. So x plus one can be written as wait. Yeah, okay. So x plus one can be written as x minus one and x minus one.
Now here you have to be very careful about the intervals where you are redefining the function.
Okay. So for values of x greater than or equal to a, no, greater than equal to minus one, then
Okay, I'll help you out in this case. See, the way to proceed this is, first of all, see what is the critical point for this mod function? Minus 1, right?
Yeah.
Because left to minus 1, right to minus 1, it will behave differently, correct?
Okay, yeah, correct.
What is the critical point for this mod function?
Okay, 2.
2. Critical point for this mod function? 3.
3.
Okay. Now what I will do is, I will try to redefine this function in these 4 zones.
Okay.
Okay. So assuming your x is less than minus 1.
Okay.
This guy will behave as negative x plus 1.
Okay, whenever x is less than minus 1, it'll be negative of x plus 1.
Yes.
Okay.
And the best way to figure that out is choose any value less than minus 1. Let's say minus 2.
Okay.
So what is minus 2 plus 1 mod?
Oh, okay, that'll just be
If this is a negative quantity, just put the answer of this as negative of x plus 1. That's it.
Okay.
That's the best way to solve this problem in a faster way.
Okay.
Okay. Now what will happen to this term? Again, choose a minus 2. So minus 2 is a negative quantity. So it will be again minus of x minus 2.
Okay.
Again, minus 2 minus 3 will be again a negative quantity. So you can write it like this.
Okay, fine.
So it will be redefined as minus 3x plus 4.
Okay, fine. Okay. So if you need to redefine this, okay, fine, got it. Fine, I understood.
So let me just write this in brackets so that we don't have to. Is this okay? Now what about? Oh, I've already reached the end of the sheet. Okay. What about minus 1 to 2?
Minus 1 to 2. Okay.
Again, start from here. Take any value between minus 1 and 2. Let's say 0 itself. 0 plus 1 is a positive quantity, so this will remain x plus 1 itself.
Yeah.
0 minus 2 is a negative quantity, so it will become minus of x minus 2.
Okay, wait. So it changes its sign.
Yes. See, the approach is the value that you put over here, 0. If it gives you a negative value, if this is a negative value,
then you change the function, or the function becomes negative.
Yeah, then there's a negative over here.
Okay, fine.
That's a trick that I'm telling you to do it in a faster way.
Okay, fine.
Now, when you put a 0 over here, what do you get? 0 minus 3, negative quantity, so it will become negative of x minus 3.
Okay, yeah, minus x plus 3, yeah.
If you simplify it, it will become, I'm just writing it in brackets, it will be negative x 2 plus 3 plus 4, that's 6. Since there is no space, I'm moving to the right. What about 2 to 3 zone?
2 to 3, then you can input a value to check.
Okay, let me write the function again over here. It has got hidden. So mod of x minus, what was the function? Mod of x plus 1.
Yeah.
Mod of x minus 2. Mod of x minus 3.
Yeah.
2 to 3, any value, take 2.5.
2.5.
This is positive, so it will become x plus 1 only.
Correct.
This is also positive, so it will become x minus 2. But this will be negative, so write negative x minus 3.
Okay, got it. Understood. Then, so that will simplify to be x
plus 2.
Plus 2. Okay, fine.
What about the interval
3 to infinity?
3 to infinity, or greater than
3. You can take any number like 4.
All of them will be positive. X plus 1, x minus 2, x minus 3. Correct?
Correct.
So that will become 3x minus 4.
4.
Okay?
Yeah. Okay.
So this is the redefinition of the function. So now if I ask plot the graph of this function, how will you plot?
Okay. So first I have to, okay.
Again, look at these points, minus 1, 2, and 3.
Yeah.
So when you are less than minus 1, how is the function behaving? The function is behaving like a line y is equal to minus 3x plus 4. Look at this.
Okay.
Correct?
Yeah.
So it will be a line having a negative slope and cutting the graph at 4. So like this. I'm sorry. And I don't have to draw the full graph. I have to draw.
And it's between minus 1 and what is it? 0.
Here.
No, less than minus 1.
Less than minus 1. I have to stop here.
Correct.
Okay. At minus 1 exactly, the function will have a value of minus 3 into minus 1, which is 3. 3 plus 4, which is going to be 7.
Okay.
So this guy is going to be at minus 1 comma 7.
Okay.
Okay. Now, in the interval minus 1 to 2. Now, what about minus 1? You can include minus 1 here, or you should include minus 1 here. Where should you include?
I think you would have to include the first one, right?
You can include at both the places. Doesn't matter, because when you put a minus 1 here, it still gets a 7. And this will also give you a 7. This will also give you a 7.
Okay, understood.
Okay. So minus x plus 6 will now be a graph with a slightly lesser negative slope. Okay, and it will go like this, cutting the x-axis at 6. This point will be 0, comma 6.
Okay.
And it will stop at 2. And what's the value at which it will stop at 2? Minus 2 plus 6, which is 4.
4.
So this point will be 2, comma 4.
Okay.
Okay?
Got it.
Now 2 to 3, it will be x plus 2. So 2 to 3, it will be x plus 2 will be like this.
Correct.
Okay? And at 3, it will stop at 3, comma 5.
Okay. Understood.
Okay?
Yeah.
And greater than 3, it will be 3x minus 4. So it will be a line like this. Okay? So we have got 4 different lines. No, 1, 2, 3, 4. Yeah, 4 different lines. This line is y is equal to minus 3x plus 4.
Minus
this
3x
line is
plus
y is
4.
equal to minus x plus 6.
Minus x plus 6.
This line is y is equal to x plus 2.
Y equals x plus 2, and that is y equals x plus 3x minus 4.
Okay.
Understood. Okay.
So let me show you on GeoGebra as well.
Okay.
In GeoGebra, the command for this is abs. Abs is for mod.
Absolute. Okay.
Absolute. So abs x plus 1 plus abs x minus 2 plus abs x minus 3.
Oh, Yeah. So it has that 1, 2, 3, 4, like 4 different gradients.
Yeah, 1, 2, 3, 4.
Understood. Okay.
So this part of the line,
Mm-hmm.
that's y is equal to minus 3x plus 4.
Mm-hmm.
This part of the line is y is equal to minus x plus 6.
Okay.
This part of the line is y is equal to x plus 2.
Yeah.
And again, this part of the line is y is equal to 3x minus 4.
Yes.
Understand how it works? Okay, question for you now.
Mm-hmm.
Redefine mod 2x minus 3 plus mod x plus 4.
Minus 3 plus mod x plus 4. Okay, I've redefined this. Then, so first I'm going to, so the points at which it touches is going to, if we were just like at 2x minus 3 and x plus 4, for 2x minus 3, the point at which it will cut the x-axis.
You first plot the
it
critical
would be
points.
3.
Critical points is the point where this is going to be 0. When is this going to be 0? At x equal to 3 by 2.
Oh, 3 by 2. Correct. Oh, yeah. Okay, and 4 is going to be 4.
Minus 4.
Oh, yeah, it should correct. Minus 4.
So the critical point for this will be minus 4. So you have 3 regions now. One, that is below minus 4. Second region is between minus 4 and 3 by 2. And third region is this.
Okay. Got it. So if it's going to be there, then so first I have to, I'm going to first take into consideration region 1. Then for values of x lesser than minus 4, I'll have to check. So when values of x are lesser than minus 4, I'm going to substitute that in there. So if I substitute that in there, then
so you have to define for minus 4, then minus 4 to 3 by 2.
Yeah.
And greater than 3 by 2. And we have also learned that you can include both the points at both the positions. Not a problem.
Not a problem. So between when x is less than minus 4, I have to first put that inside the function, right? So so when it's less than minus 4,
take
minus 5.
Take minus 5. Okay.
Minus
so when you put
3.
a minus 5 in just this part, the inside part.
Yeah.
What do you get?
Minus 13.
That's a negative quantity.
Yeah, the negative quantity. So it'll be 3 minus 2x.
Yeah, or minus of 2x minus 3.
Yeah. 3 minus 2x. Then if I put in negative 5 in that, it would be minus 5 plus 4, which is again negative, which is minus 1. So if it's minus 1, then what happens? Then it has to be negative, so it's going to be minus x minus 4. Okay, so here it's going to be minus 1 minus 3x.
You can calculate it here itself, so it will be minus 3x
minus 1. Okay.
What about this? Minus 4 to 3 by 2?
Okay, I'll take 0 then. If I take 0, then what will happen? It'll be minus 3. Okay, the first will be negative. So it'll be 3 minus 2x plus, and then next one will be positive. So it'll be x plus 4. So it'll be 7 minus x.
So it'll be minus of 2x minus 3
plus
x plus 4, correct?
Yeah, 7 minus x. Then when x is greater than or equal to 3 by 2, I can take any value. I'll take in 2. If I take in 2, then what will happen? 2 into 2, 4 minus 3 is positive 1. So it'll be 2x minus 3 plus 2 plus 4, which is 6. Again, positive, so x plus 4. It'll be 3x minus 1. Yeah, it'll be 3x minus 1. So I can divide it into
3x plus 1. No?
Yeah. So you have y 3x minus 1, you have y equals 7 minus x, and then you have y equals minus 3x minus 1. Okay.
So first plot the critical values, that's minus 4. 3 by 2 will be here, that's it. So how will it behave before minus 4?
Before minus 4,
it will be
it has a negative gradient.
Negative slope line. It's very important to know this point actually.
Yeah, so if you put in minus 4 there, then it'll be 12 minus 1, 11.
So it's minus 4 comma 11. Okay?
Yeah.
What about this interval minus 4 to 3 by 2?
Minus 4 3 by 2, it'll have a negative gradient again. And at 3 by 2, what will be that? It'll be 7 minus 3 by 2. 7 minus 1.5, which is 5.5.
This point will be 3 by 2 comma 11 by 2.
Yeah.
Then again?
Then again, between 3 by 2 and infinity, it'll have a positive gradient, and yeah.
Let's check this. What was my function?
Mod of 2x minus 3 plus mod of x plus 4.
See that?
Okay.
So this line is what we found at as 3x minus, what was that? 3x minus?
3x
minus 3x minus 1. Yeah. This is 7 minus x.
Yeah.
As you can see, y-intercept is also 7.
Yeah.
And this is finally 3x plus 1.
Okay, fine.
Now, something very interesting that you would note about it. When I asked you to plot the graph of mod x minus 2, you actually plotted it like this. So we shifted it 2 units to the right.
Yeah.
Correct. So this point becomes 2 comma 0. Okay. There's a way to do this in a faster way. In fact, I can give you mod of any function that I would like. Then the approach is what I'm going to tell you next. So for that, you just first draw y equal to f of x graph. For example, in this, I would draw y is equal to x minus 2 graph. Okay. That would be a line like this. Correct?
Yeah.
This is y equal to x minus 2 graph. Okay. Now, the part of the graph which is already above the x-axis, don't disturb it. Let the part be as it is. But the part which is below the x-axis,
you reflect it above the x-axis.
You reflect it about the x-axis. That means you make it like this. And erase this part. And erase this part. Okay. Okay. So first draw this, and second step.
Yes, then you would it would be the negative. It would be negative of that, because it would be minus y, right?
Yeah. So for all these values, your y was negative, right?
Yeah.
So mod role was to actually send it to the positive side. So something like minus 1 got sent to plus 1 over it. Okay.
Okay.
So the rule is, second step, don't disturb the part which is already above x-axis, and reflect the part which is below the x-axis to above the x-axis.
Okay.
Okay. So for example, if I ask you plot y is equal to mod of x square minus 3x plus 2.
Y equals mod of x square minus 3x plus 2.
How will you do this?
Okay, how will I do this? Fine. So first, I would have to okay. So first, I'll first draw the original graph, and then reflect it, right? Reflect the part which is below the x-axis, above the x-axis, and don't disturb the one that is already above it.
Yes.
So first, I'd have to plot this.
So first plot without the mod.
Without the mod, yes. Without the mod, if I plot it, then what will happen? It will be minus b by 2a. So
it will be a parabola like this.
1.5. Correct. So let me just like write down like the important points in. So that will be okay. So the vertex should be at 1.5 comma 0. Minus 0.25 minus 0.25. Then okay, then when does it cut? Oh, it cuts at 1. Okay. Now what I'd have to do is I'd simply have to reflect this above.
So this part is already above, right? These two parts are already above the x-axis, so don't disturb them.
Yeah. So if I have to reflect it there, then my vertex is going to have to become minus 1 by 4, right? So it's going to have to become 1.5. No, not 1. Yeah, x will be the same, but y will become 1.5, 1 by 4. Yeah.
So it'll be like this.
Correct. Yes. Okay.
So now this point will become 1.5 comma 1 by 4. Okay?
Yeah.
Understood? So only the part which is below, you just have to reflect it above. What is already above, don't disturb them.
Yeah.
Let's check it out. Y is equal to abs x square minus 3x plus 2. You see this part? Small part?
Yeah.
Okay. Fine. So I think you'll be able to solve few more questions on the worksheet which I sent.
Yeah. Okay. I will be able to.
So do that. Do as many as you can.
Okay.
So in the next class, which will be on Sunday, I guess.
Yeah, Sunday.
I'll talk about more other transformations.
Okay.
And some more special functions like GIF function, fractional part function, all those things. Okay.
Bye.
Okay then. Thank you. Bye bye.
Thank you. Bye bye. See you.
See you.